push that rock here with some math. Let's solve a logarithmic equation where we need to use logarithmic properties to simplify before we go through the solving steps, okay? So I have an example here, right here. You will notice we have a log added to the log. Can you guess what logarithmic property we need to use? That's right, we need to use the sum of logs property. Before we do that though, we have to be careful with these logs. In the last video I should have mentioned that you got to remember they have domain restrictions. In the last two, the answer was well within the domain, but this time it's going to cause us some consternation. So let's look at the domain of these logarithmic expressions. Remember, the argument of a log must be greater than 0. So this argument, negative x, must be greater than 0. To get rid of that negative, I need to divide both sides by -1. When I do that, I get x is, flip that sign, must be less than 0. So x must actually be a negative value. That's right. If I put a negative value in for x, the double negative becomes positive and the argument would be positive. So my inputs must be negative on this one. What about the other one? The other argument is 24 minus x, and that must be greater than 0. So here, if I add the x over, I get 24 must be bigger than x. That's the same thing as saying x must be less than 24. Well, obviously, if I'm using negative numbers only in this one, I must be using numbers less than 24 because all negative numbers are less than 24. So the takeaway here is we must choose numbers that are negative for the input. So we need to remember that when we get our solution to this equation. All right, we're ready. Let's use that sum of log properties that we mentioned. When you have a sum of logs, you can get a single logarithm, but you multiply the argument. So I'm going to have a negative x multiplied by 24 minus x. So we use the sum of logs property to turn it into one log. Now, before I go any further, I'll go ahead and simplify inside the argument. So I have log base 5, okay? Can you see that? Am I blocking the view? Of negative x times 24 is a negative 24x. Negative x times negative x is plus x squared, and that equals 2, okay? So there's our logarithmic equation. We're ready to solve it, and we're going to use the definition of a log. The base of this logarithm is 5, so we can write it as a base. Now, every base has some exponent that you put up here as a superscript, and that exponent is the value of the log. So this log is equal to 2, so the value of the log is 2. That becomes the exponent. So we have 5 squared. And then that equals whatever the argument is. Well, the argument is x squared minus 24x. Uh-oh, we have a quadratic equation, okay? So we're going to set this equal to 0. We'll subtract this over. So the x squared is positive. We have minus 24x, and then we're going to subtract this 5 squared, which is 25. So we're going to minus 25, and that leaves this side 0. So now I have the quadratic equation set equal to 0. We'll try factoring. If factoring doesn't work, we'll use the quadratic formula. But let's try factoring. So what times what gives me x squared? X times x. X times x will give me x squared. What times what will give me 25? Well, 5 and 5, or 1 and 25. Let's try 1 and 25. Now I need it to be a negative 25. So one of those has to be negative, the other one has to be positive. Well, if I make this one negative and this one positive, then I can see that negative 25x and 1x, when I do the outer time the outer and the inner time the inner, I'll get negative 25x and 1x, which adds to negative 24x. So that is the correct factorization there. So I set each factor equal to 0. I have x plus 1 is equal to 0, and x minus 25 is equal to 0. And so my solutions are x equals 25 and x equals negative 1. But wait a minute. We said the input, the x, had to be less than 0. It must be less than 0. 25 is not less than 0. We call this an extraneous solution or an extraneous root. So this is extraneous. It is not one of the answers to the original equation that we were trying to solve. It is a solution to this equation, this quadratic, okay? It's even a solution to this step, but it's not a solution to the original equation that we started. So -1 is the only solution. It's the only one within the domain of being less than 0. That's the solution to the equation. And that's how you do that. I, G, G, Y. Math made simple. Simpson Math.